Hi, good afternoon, everyone. Can you all hear me? Are we good? OK. Good afternoon. My name's Neil Stevenson. I'm from Hazelcast. My talk today is caching made Bootiful as a joke on Spring Boot. We love Spring Boot. I'll start. For those of us that have been following the Twitter stream, we have to put up the disclaimer that I build Hello World applications. If you follow Twitter stream, you'll have seen that retweeted, so I had to put that out there. So this talk, Caching Made Bootiful, is hopefully a flavor of caching that you might not have heard of. So Spring Boot, which you'll know, Hazelcast, which you hopefully know about, and the Java caching standard, JSR 107. There's a working example, which was working when I tried it earlier. You can download it from GitHub, have a try yourself. As a deviation from standard, I'm not going to do Hello World. I'm going to do the Fibonacci series, a mathematical calculation that you might have heard about. What the Fibonacci series is actually about, if you study the paper, is rabbits. He was trying to model how rabbits would breed. So a male rabbit, a female rabbit, gives you more rabbits. Then you've now got all the rabbits you had before, who then give you more rabbits, and so on. So the number goes up very quickly. Since there was the reference to mono meaning monkey, those of us who want to learn Spanish, it's conejo for rabbit. A little bit of side knowledge, but this function is very easy. The third number is the sum of the second number and the first number. The fifth number is the sum of the fourth and the third. It's a nice little example for recursion. So that's the problem domain. This is where we want to do caching. So let's just get straight into the code. I'm going to mix and match. There's 5 examples in my demo. All right. How do I swap screen? There we go. So I'll talk you through the coding. I have defined a Fibonacci service, which takes a number in, give me the 10th number in the series, and gives you back a number. This is the service, and then we'll refine it with multiple implementations just to see how things go. But for now, we're going to do version 1. And version 1 of this service is here. And this is the coding. Don't really care about the coding. So let's start it up. Version 1 target. Spring Boot. Now, there's a little bit of logging going in here. I have, while this starts up, I've defined a debug mechanism. And what this is looking for is a cache manager object and logging it out to the screen using Lombok. We have started up, and my cache manager is null. So we're not got any caching. This is what we're trying to see to begin with. So if we do, let me localhost 8080, and let's pick 45. And start counting. I was originally going to do 48. There we go, 6.7 seconds. Let's make that a little bit larger. And if I refresh the page and run the calculation again, and wait, and wait, and wait, 6.9 seconds. Same sort of time. So this is the problem, because that's not any good. Here's one I did earlier. 48th number takes 28 seconds to calculate every time I try and do it. When I get to the 50th number, 75 seconds. Well, that's me unhappy. So this is where caching comes in, and we all kind of think we know what a cache is. So, for examples, it's a convenience copy of data you've got elsewhere. Normally, when we talk about caching, we're thinking about speed. The data that's elsewhere is slow to retrieve. But it might be the data that's elsewhere is expensive to retrieve because perhaps you're charged each time you do a retrieval, actual money. Or it might be you have to derive the data, rerun it, which is what the Fibonacci thing does. You know, the 48th answer, we run it twice. It runs the calculation twice. It takes, what was that one, 28 seconds twice. Unacceptable. This is where you start to think about things a bit differently. How's a cache different from a materialized view? Is it this? Is it an event source? It's like you've got data that's come from one place to become data in another place. And for luck, Ebola, a bad thing. You know, the cache can be a bad thing because there are complications you have to consider. So let's start with the complications. It's a cache, it's a copy, it's a duplicate. So how do you keep the two copies matching? You have synchronously changing. When you change one copy, you change the other one at the same time. So that runs at the pace of the slowest. But they match. You've got asynchronous, where you change one and then later change the other. Not immediately. And that means they temporarily don't match, and depending on which one you're using, that's maybe good, maybe bad, maybe tolerable, maybe intolerable. And when it's really bad is if you're changing both copies at once. Then they meet in the middle, and who knows what's happening. So that's a bad thing. And this is where you have to start thinking a little bit differently. Where you start, you normally say, let's cache the result. But you're still kind of thinking the primary copy is stored in a database, stored in memory, and we just start using this copy up in memory because it's faster. And then after a while, you might think, or you might not think, this is the copy I'm using, so this is the copy that matters, and we save it somewhere for legal and audit purposes. We never read it from the disk. It's a write-only store, perhaps. So that's where you kind of have to start thinking differently. Is this really caching? So let's get some caching going. And this is the easy part. For those of you that are Spring developers, this is really straightforward. So close that down. So here's my function in version 1. All I need to do is change it to version 2. And there's really just two changes you have to make. You have to annotate the method with the cacheable annotation. So what we're caching here is the method result, not the data. So we're caching the calculation. And we're going to give the cache a name, Fibonacci. And it's annoying you have to do two things to achieve one outcome in Spring. So maybe this is me being stupid, but you also have to turn on caching in Spring Boot to get it to do this. So turn on caching, and this is what I want to cache. 2 steps, I'd like it to be 1. So now if we start version 2, and I'm going to stick with 45 because it runs reasonably quick, unlike Spring Boot. So what we're waiting to see is what my caching provider is. So all I've changed is an annotation. Give me some caching. And Spring Boot has plugged in the default concurrent cache manager, which is concurrent map, basically. So now, when I refresh the page, remember the JVM's been restarted, so this is the first access to the Fibonacci function. about 6.7 seconds. That seems to be the standard here. And if I refresh again, whoa, 1 millisecond. This is what we're wanting. Zeros. Yeah! That's pretty good, really. On the top abstract, it talks about add 12 characters. So that's 1, 2, 3, 4, 5. So it's not that one, and it's not that one. It's 14. Not many characters is perhaps the way we want to think of it. So that's a good start, you know. Oh. I'm happy. And this was my result when I did it with 50. The second time, the subsequent time, I'm now getting instantaneous results for something that took 75 seconds. Whoops, we've got a slide out of order there. Now it's time for Hazelcast, which is something a little bit more easy to get going with, great for caching, great for other things. The idea with Hazelcast is it's a distributed Java util concurrent map. So you've got 10 servers. They look after a slice, a 10th each. So you can push a lot of data in. If that isn't enough, you go to 20 servers, and they take a 20th each. So you can scale up or down, depending. And the way Hazelcast works, the easy way to get going, which we'll do in version 3, is it's just a jar file that you depend on. So your jar file, your Spring Boot app, contains an instance of Hazelcast. That instance of Hazelcast will talk to other instances of Hazelcast and share the load. So this is what we call embedded mode. It's like your jar file appears to be standalone, but it's accessing data that might be hosted somewhere else, but it's invisible. You're just using the Java util map interface, puts, gets, and back it comes. And if you want more sophistication, you can externalize Hazelcast and run Hazelcast on its own, and then use essentially a proxy from your jar file to connect to Hazelcast across the network. And once you use that approach, you can be non-Java, if you like, because it's just a protocol between the two. So, better caching. Better caching with Hazelcast. Let's see if it's better this time. So, now we're going to go to Func version 3. And in version 3, I haven't changed any of the implementation. What I've done is I'm telling Spring Boot to use Hazelcast as the cache manager. Don't use the default, use Hazelcast. That's it. So that's not difficult. So now we start up version 3. You'll get a little bit more stuff now because, as I mentioned, Hazelcast is now embedded inside the application, so there'll be more logging coming out. Up it runs, and then here's some Hazelcast messages. Hazelcast is starting up. Whiz by, but now what matters is our cache manager is Hazelcast. So where we can go with that is first call should take, what, 6.7 seconds? 1, 2, who's counting? 7 seconds. My machine's slowing down. Second call, faster, faster, faster as the JVM heats up. Now, there's a little bit extra going on now because now it's got to talk to Hazelcast, but fundamentally, the response time's massively improved. Hey, we got it down to 0. You just need to let the JVM heat up enough. And where this is useful is now this is a little bit more visible because Hazelcast has a web GUI. And we can look at the Java util concurrent map in the GUI, and we can see the data in there. So if we wanted to look at the 45th data item, there we go. There is the value 181, blah, 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 blah. which is hopefully the same as that 183. This will be embarrassing if it's not. Yep, it's good. So now we have a little bit of visibility onto our data. And because we have visibility onto our data, who can spot the mistake? We only have one entry cached. All we've cached is the 45th calculation. So if we run 46, it still does the recursive call to 45 and 43 because it's bypassed the cacheable annotation. I'll show you on the code. There we go. So this takes a lot longer. And it's like, what? And the reason it takes longer is what we're caching is the method, but then we're calling the method with this. So we're not passing through Spring. It can't intercept. And also, this is an embedded Hazelcast, and we want to show Hazelcast in client-server mode. And let's go to example 4 then. So that was better with Hazelcast. Hey, we can see the results, and we could see that there was a fault in the results. Maybe not a fault. So if that was better in English, it's like good, better, best. Here's the next superlative. This is better caching. We're going to go best caching. We're going to go best caching with Hazelcast client connecting to Hazelcast server. So in order to do that, I need some extra windows. So I will start up a Hazelcast server. And give it a second to start. The way Hazelcast works with Spring Boot, Hazelcast normally uses an XML file for configuration, or you can do it from Java. If Spring Boot finds the XML file, finds Hazelcast on the class path, you want Hazelcast. So it's built us a Hazelcast server. Now we'll run just before I do that, let's see what processes are running. So the server is that process. That will come in handy. There's the server. Here's the client. So now we're starting version 4. Let's have a look at version 4's code. I mentioned the XML. It's just a file. Say, you're a client. Where do you connect to? Well, you just give it an IP address or some IP addresses. That's where the servers run. On this demo, they're running on my laptop. I was going to run them on, you can run Cloud Foundry and run that with Spring Boot. Lots of ways you can do it. But the code is not really much different. We still do this business where you pass the Hazelcast instance in to Spring as the cache provider. Now, we have to, on Spring Boot 153, create the Hazelcast client explicitly. Spring Boot won't do it for us. There's a request in the queue for it to do that, so this bean won't be needed in later versions. I haven't tried yet, but I think it might be in 2.0. So now our client has started up. There's the client's cache manager. If we look at the processes, we now have version 4 is running. It's a client, so when I do let's go back to 45. So now that took a little bit of time. And now it's faster. And if we look on we now have 46 entries cached because what I forgot to show you is that I changed the implementation. So I'm now plugging in the service into itself, which I was surprised you're allowed to do, but now you can run the method through the service, and each of the recursive calls gets cached. So that's given me the 45 in a row. So if I now run the 47th, I've got 45 to 46 cached. It's virtually instantaneous because the result of 47 is the result of 46. I did 45, and we have those already. So we've done a bit of a score. So this is better because We have visibility onto the maps. We've got scalability. It's a client-server model. You know, you've detached your storage from your processing. You access them across the network. As I mentioned, we can scale the processing up and down. So let's actually do that. So what I can do is start a second server on my laptop. If we look at the management console, we should see it start up once it heats up. Is it heating up? Is it heating up? There we go. So it's found, whoops, scroll back off the page. Up here, the second server has found the first that formed a team together. If I go to the, and there's two of them on the management console, and if I look at my data, I see that the 46 results are now half shared across the cluster. So we have a primary copy and a backup copy, and the primary copy of result 46 is on one server, and the backup copy is on result 40. The backup copy of 46 is on another server. And that's an important thing, because I'm going to kill one of the processes. This was the original server I started. And now it's not there. It'll disappear off the console in a second. And what we'll see there, it's gone. So we're left with the one on 5702. If we're a client, our response time is still pretty fast. So now, in addition to having visibility and scalability, we have got robustness. And that's an important thing. Some of you might be wondering why I've got a second laptop. It broke. I lived the dream. You've got to carry a spare. 1 + 1 backup. That's a good number. It means you can accommodate a machine breaking and still keep going. 47 minutes ago, the hard drive's mangled. So that's, back to the slides. That's just a much, much better thing. But that kind of takes us deeply into Hazelcast land. And it might be you don't really want to get that heavy into Hazelcast, which, oh well. So what you want to look at is JSR 107, the Java caching standard, which has been one of the longest running Java standards, but provides a standard framework for caching, where objects are created in a cache, much as we might know, and Hazelcast is just an implementation. You can plug it in. Hazelcast is super fast, but if you want to swap something else in, you can do that because it's an implementation. So all you need to do is import the Java standard, the API, javax.api, and move Hazelcast as a provider, use anything as a provider, and you've got caching in a standard form using standard options. So this is where best of the best. So when I was doing these slides, it was like good, better, best, and it's like best of the best. It's like even better if you like that kind of thing. Because there's a little bit of standards going on, there's a few things that are slightly different from what I've shown you previously. So let's go with, just close a few of those windows down. So now we have version 5, and what version 5 does, not much different. Standard Spring Boot app, enable caching. Exact same service. We're still using cacheable. Little bit of stuff going on in the config. 2 beans. Again, 2 seems too many. We set some system properties to tell Spring to use JCache. We set some properties to say it's going to be the Hazelcast client. And that's it. And then we build a Hazelcast client from the client configuration XML file, which looks like this, and plug that in as our cache manager. So where are we? We don't want version 4 anymore. We're running a server. So now we can do version 5. Now, one of the things that Hazelcast was caching those results in a map. Jcache, they're called caches. So when we looked on our console page, we had, here are the maps we've defined. We've also got a tab for caches as well. So we should see that once my caching starts up. My cache manager is now a Jcache cache manager, a standard cache manager. Yeah. Well, I'm happy. So again, this is the first time we've used Jcache, 481 milliseconds. The second time it's down to 2. It'll maybe drop to 0, depending on how my machine is doing it. It's dropped to 1. We can keep calling it. And if we look on the console, we now have, how many results there? Now, this is a thing I noticed earlier. We've actually got 48 results because my calculation is wrong. It also calculates the Fibonacci of 0. It should stop at 1. If you look at the rabbits, then 1 rabbit can't breed. No rabbits can breed. You need 2 at least, and 1 of each. But, you know, the same stuff is there. The key is long. Let's have a look for, I don't know, number 4. What's the Fibonacci of 4? So it goes 1, 1, 3. Is it 8? No, it's 5. So all the results are there. The one that shouldn't be there, my algorithm's gone wrong, and I've stored the answer for 0. It's not really the biggest thing, but because we have this visibility, we can be doing debugging. But there's other ways we can do debugging, because when we define our XML, I purposely left this to the end. We set up the server with the various bits of configuration. So here's where it's sending its results to display on the screen. Here's how it connects to the others. What I've added, you define a cache. In Hazelcast, when you create a map, it creates it on demand. In Jcache, you have to pre-create it. Not a big pain. But you can add a cache listener. So what you can get, if I look at my code, the factory creates the listener. My listener gets called with some cache events, with some changes to what's in the cache. In this case, creations. So I'm listening for cache entries being created, and I'm logging them out. And if I look on the console, there's my cache entries being logged. So that's the thing you couldn't do before. And that is a massive, massive thing, because that gives you a way to do reactive programming. You're now getting told when data is changing. Something's gone in the cache, we can do something about it. Something's left the cache, why would it leave the cache? Because you might have configured the cache, which you can do on Hazelcast maps and Jcache's caches to have expiry so that you don't fill them up indefinitely. You can discard items after you've not used them for a while. Or you can keep them as long as you can afford to keep them in memory. So you have other options on Jcache that you don't have with a standard cache. So that's why I'm calling it best of the best. But you know, what are these other options? So we've got listeners, we've got a kind of way of doing event processing. The data has changed. I'll tell you, you can do something about it. Your code might do who knows what, send an email. Don't know, your choice. The second thing you can do on caches is you can have what we call cache writers and cache readers. You can connect them to an external store. So if you're putting something in the cache, that might be the point at which you save it down. That's the point at which you put it in the parking space for later, for legal and audit people. Every time you've changed something, you've recalculated a new Fibonacci number, you can have a cache writer that calls custom code that does something with it. Writes it to a log, writes it to an event stream, writes it to a database, whatever. So, we're happy. Yeah! Or I'm happy. So, one more thing I meant to mention, just as we head towards the end. If we're all Spring people, there's a Spring data module for Hazelcast. You can use Hazelcast like it's a repository. So you can do saves, find alls, all the usual kind of stuff. You can get it to build queries. It's a key value store underneath. So it's using Spring Data key value. I always mention it because I wrote a good proportion of that code. That's what I do. So Hazelcast is good. Spring Boot's fantastic. They go nicely together. Caching is easy, easy, easy to add. But remember the thing I said at the top. If you take away nothing, just remember Ebola. That was the 5 things. Item A was good, B was good, C was good, D was good, E was bad. If you've got 2 copies, you have to think about what you do for synchronizing them. Think about what happens if they differ. So if you have pulled data in from a database, how will the cache know if the database has changed? Typically, what you would do there is expiration. So you would say, flush it out the cache after a while. If it's not been read for a while, not been written for a while, that's a little bit uncontrollable, because if you're keeping it for 5 minutes, then on average, it's stale for 2.5 minutes. Somebody's changed the master copy, you've got the backup copy in memory. So you definitely have to think. Caching is easy to add, super easy to add. 12 characters, 14 characters. You just enable it on the application and put cacheable on top of your methods, and you're away and running. Let's see if this works. Let's check I've given you the right URL. I have indeed. There we go, caching made Bootiful. So you can download it, have a play. Question and answer. Anybody? Yep, got a question.
What if we want to prevent caching the 0 value, for example, here?
Right. So what you want to do is prevent a value going into the cache. So kind of like filter it. I'm not sure if you can do that on JCache. On Hazelcast maps, remember we mentioned those listeners, those are kind of after-event processors. You can have a before-event processor, which can reject certain values, so basically discard it. So it's kind of like an extra level of validation. So definitely you can do that on Hazelcast. I don't know off the top of my head if you can do that with JCache, because it's a caching standard. I don't think you can, but the caching standard is not set in stone. It's evolving. We've got version 1.0, now version 1.1. You know, it's probably not going to change substantially. But yeah, definitely it can be done. You might also want to say, well, rather than get rid of data when you're when it's not been used for a while, expiration, you could do it based on space. You could say, get rid of my data when I'm low on heap, or get rid of my data when I've got more than 1,000. So there's lots of ways that you can trim down how much you store. Typically, when you do these things, you want to use some sort of least recently used, least frequently used kind of mechanism, just to get rid of the ones that are the least painful. You have to think of it that there's cost somewhere to rebuild the cached value. You might have to rerun a calculation, retrieve it from somewhere else. Next question? No?
Your console showed Hazelcast Enterprise. What of what you showed is possible with Hazelcast open source?
That actually is open source. Just it's in the. If you go to the Hazelcast website, Hazelcast. There's a hazelcast.org for the open source. and hazelcast.com. Then, where are we? You can download it. Let's see how fast it works. Version 182, download will begin momentarily. This might take too long. Let's see. On this GUI console, you don't need a license if you're running 2 nodes. It's only when you're on to larger numbers. So yes, we'll take the next question while this is downloading. But where's my download going? Nearly there. Oh no, it doesn't know how big it is because I've downloaded a zip. So same question. Yep. Hazelcast itself is open source. It's been open source since day 1, 2008. You can go to github.com/Hazelcast, download our code, use it. I work for Hazelcast.com. I'm an employee, so that's where did we go to? Hazelcast roles. You've got to try it yourself. Don't believe me, try it. So we're about done.
Hello?
No more questions?
I have one.
Oh, yeah.
How can you execute the method while retrieving stale data, but the execution of the method updating the cached value?
I can't quite hear you. Could you repeat the question?
I'm repeating. How easy it is, or do you have an indentation that allows for quick retrieval of cached values, but allow for method execution to update the cached value asynchronously?
So when you're storing data in like a map, you can have multiple clients connected to that map. So one might inject data, somebody else might read it. If you remember when I restarted my client, all the data was there, so it didn't have to rerun. So it's caching it in the server. All I've done in my example is doing a write, but you can do an update to data, you can change it, and that's where you get into all sorts of extra architecture patterns. It's like this is an update as opposed to a write. So just for pure caching, it's normally done as a creation. There we go, I've downloaded it. There's the management center, and there's a start script. So you can run that for yourself for no problem. Did I answer that question correctly, or was
More or less.
Yeah, so basically, data that one client puts into the cluster or one server writes to the cluster, anybody else can access. It's communal.
Without wanting to take too much of your time, imagine that I have a third party that for some reason populates a shared database, for some reason. And I have a service that makes reads on that database, and it's a long read. So I want to cache this value to optimize this read. It's just a read, but I want to have cached values. I can cache this for some time, let's say 1 minute or something like that. And for 1 minute, that value is cached, right? The thing is, when that entry expires, after 1 minute, I'll need to get the data again, right? What I'm asking is if it is possible to return the stale value while allow for running of the fetch of the database, for instance, and cache it again without impacting that one call to cache the value.
I think I understand what your question is. So normally what we're talking about here is what I would call, well, if we think about writes, first of all, remember I mentioned there was a synchronous write or an asynchronous write? The kind of pattern for that is what's called write through, where you write to one store and to the other store. And the write behind is where you write immediately to one store and do a delayed write to the slower one. What you're asking is, can you do the reverse on reads? So you go to read the cache, and you do like a background refresh. So you return.
Yeah, exactly.
Yep. So we actually not yet, but that's coming in Hazelcast 3.9, which will be out in the summer. So today, no. Very soon, yes. So it's like this refreshing strategy that you want to say, because normally what you do is you would discard it from the cache so that it's recreated. What that means is somebody gets poor service. somebody gets that call where it takes 76 seconds, and that's not what you want from an application. So what your question is really saying is there a way that you can refresh it without deleting it? And you can do that yourself, but we're building that into the product, and that will come out a couple of months' time.
Thanks.
Okay, yep, more questions?
Hello over here.
Okay, so does Spring or Hazelcast support something to prevent cache stampede? When you have competing clients to calculate same result.
Yeah. So you're asking what happens if two people try and do, right, so
Exactly.
the model in Hazelcast is that if there are two writes, they happen in the order that they get to the server. So one person might overwrite the other person's data, and that's again where that pre-interceptor, the pre-change interceptor code comes in useful. Ideally, you don't want two people doing updates to the same data so quickly that one is going to overwrite. You know, you write in that, think of something, you write in that the coffee is hot, somebody writes in the coffee is cold, and it's like, well, only one of those values will exist, and if they happen one after the other, then that's not really a good way of handling concurrency. If you have an interceptor, you can block one of them because it's since been invalidated by the other. But much more, it's a kind of application problem. You don't want two people updating the same data at the same time, because that wouldn't really matter if it was Hazelcast or anything. You know, any database, any storage thing where it's like, how is it likely to happen? And if it's likely to happen, that's where you want to think towards locking mechanisms, you know, compare and set. And that slows down everything. And then you have to handle the fact that your change might be rejected. So the default way is it just replaces it regardless, in the order that they come in. There's an algorithm that determines what gets stored where. So although it's sliced and spread across a cluster, it's predictable, so you can make sure that two connections send the right data to the right place, and they will happen in the order they're received. There's a question?
Does Hazelcast support deserialization for different versions of the application?
So you mean like a portable object where it mutates?
Let's say I have two applications, same application, but two different versions running in my ecosystem, and they have two different models. So is there any support for this kind of case?
So Hazelcast has 7 forms of serialization. You can, if you remember I mentioned there's like a client and a server, passes data across the network, so you have to flatten out an object, transmit it as bytes, and if you're going to do anything with it, unpack it at the other end. You don't have to unpack it. Java I/O serializable is just the easiest way to get going, but doesn't support that mutation. Hazelcast has a portable object format where you can define an object that's got a certain version. Here comes a version 5 with 8 fields, and I know about a version 6 with 9 fields, so I'll enrich that object and initialize that extra field, so it's now a version 6 object. So yeah, you can do versioning, you can do object mutation. These are all complicated things to do, so there's a website, Hazelcast code samples, github.com/hazelcast/hazelcast-code-samples. Hopefully there's one in there of that. Let me go to github.com. Hazelcast. And under the serialization section, so if you wanted to do portable, protobuf, Java I/O serializer, stream serializer, you can plug in things like Cryo, Avro. You don't have to write it yourself. You know, these things are You can write it yourself, you can take control, you can optimize, or you can delegate to something else. You might just do Java IO serializable because it's dead easy. It's not the fastest, but it's dead easy.
Thank you.
More questions? Okay, we're done. Thank you.